Thank you. Terima kasih. Assalamu alaikum. Good morning. It is a pleasure being here. This is my very last week here in Malaysia, and I'm delighted to be back. I was here on Tuesday, and I love your campus. It's beautiful. This is a great university. I really learned a little bit about what you do here, and it's very exciting to see Malaysia continuing developing and using science and engineering to move forward. What I would like to do today is a couple of things. Is present you with some of the grand challenges, or what we consider grand challenges in science and engineering, and also how graduate students are dealing with these challenges, and also how the National Science Foundation, which is the organization that I work for in the US, how we are approaching the training of the graduate students in the sciences and engineering. I also, for those of you who don't know much about the National Science Foundation, I brought a 5-minute video to start out, and so to kind of put this presentation in a context. So the reason why I call this grand challenges is because I know that you're at a university that focuses on research and entrepreneurship and innovation. And the grand challenges that we have now are those who we look at as some opportunities to advance research in some of these big areas. And then once we find solutions or potential solutions to the grand challenges, those are the ones who are going to result in the well-being of people and also sustainability. What I have here is a couple of reports that were presented or were completed by the National Academy of Sciences in the US and the National Academy of Engineering. And they have identified some specific challenges in the engineering and in the scientific areas. And these reports present something about what it is required to deal with the challenges. The grand challenges for engineering are multiple. I know that this university has a lot of engineering areas, and you cannot see very well, but they're outlining in this report what it is. For example, you enhance virtual reality, you have access to clean water, you looking at managing nitrogen cycle, and doing energy and other areas that are very important. And also in the biological fields, there is a report that specifically addresses, the National Research Council addressed how biology needs to be taught in the 21st century to address the big challenges that are facing us today. So some of the grand challenges, you probably know about them, you hear about it in the news. One of them is energy. We're faced with energy shortages all over the world, and climate change that affect us all. We hear about tsunamis. We had this big storm in the US a few days ago, and a lot of those are related to the climatic changes that are happening in the world. Water is a very important issue, especially in Africa and other parts of the world. Shortages of water, we hear about them every day, and also water quality. Then food. Food is a very important area. I was at this Global Science and Innovation Advisory Committee yesterday, and food security and food availability, it's a big issue, and we have to deal with every day because countries are concerned about food. Are we going to have enough food to feed the world? And not only that, is the quality of food going to be good? I learned yesterday that there are also issues related to nutrition here in Malaysia, health issues like diabetes and high blood pressure related to the food quality and the diet that might be affecting people. So food is another issue, and of course, food or nutrition or bad nutrition affects health. And overall, it affects the overall safety of people on Earth. This is just to give you an idea of projections of climate change from 2090 to 2099. And this shows you that what you probably know, and everybody knows, that the planet is getting warmer. And we are going to see what is projected is not the cooling of the planet, but the even warming of the planet even more than what has happened up to now. And the consequences of that are very severe, particularly when you start looking, again, at issues up here like water. Some areas are going to be experiencing severe droughts because of climate change, but other areas are going to have floods because they're going to be the melting of ice up in the temperate zones, and that's going to have an effect on the sea level. So we're going to have that. So everything is almost like a chain reaction. The ecosystems are going to be affected. We have here, some of you might have heard about coral bleaching. That is a very important area in the oceans. Ocean acidification, another big area, important area that we have to deal with. And food that I mentioned, that food is complex. There's also related to food productivity, especially big grains like wheat and maize are going to be all the big crops that feed the world, and you have here rice. Those are going to be affected. For example, here in Malaysia, if you don't have water, you cannot grow rice. Or you have to be looking at how can you grow rice without much water and start looking at maybe potential different types of crops that you can grow. And again, that's going to affect the coast. There's going to affect how people, not only the people who live in coastal areas, are going to be faced with very important issues because the ecosystems are being affected. And as I mentioned earlier, a lot of these challenges and a lot of these very complex problems are going to affect the overall health of people. So what I hope that these videos work, and I have to tell you what these videos are all about before I start. The quality of the videos are not very good because they're made by graduate students. We asked some graduate students to submit as a competition about how do you see that the world can be improved. And so some of these videos that I will show you have, as I said, are made by students, and so some of them are better than others. But the whole idea is that you will see how they see and what they see is important for their future. Thank you. Well, basically, I'm going to, since you probably couldn't hear it well, but what she's saying is welcome to my world. And that what she's seeing is that she wants to blend organic and inorganic chemistry to solve all these problems, like she said, energy and other issues, pretty much the grand challenges, and how she's seeing herself as part of the solution instead of part of the problem. Let's see. I think I'm just going to hold it since I'm going to be putting it here. So we'll just see how this thing works. Okay. Now, what we have done in the US in the past, we train graduate students in very specific disciplines, where you either become a chemist or a physicist or you become a biologist. But now when we look at all these grand challenges, it takes different kinds of people. And it takes a team of people to approach one particular problem. So, so you cannot just solve things alone. And what we are doing now is trying to train the students with multidisciplinary views, with this interdisciplinary training, and that will prepare the people to work better and solve the problems in a more holistic way. This cartoon is basically to illustrate how this person says, I am on the verge of a major breakthrough, but I'm also at that point where chemistry leaves off and physics begins. So I'll have to drop the whole thing because they cannot integrate physics and chemistry. So But again, you know, when we start looking at the grand challenges, first they're interdisciplinary, and secondly, they're very complex. They're not easy things to deal with. The other thing is that we start thinking about scientists or engineers, but it takes other types of people to solve problems. You need politicians, you need social scientists, you need decision makers, you need industry, you need many other components to start looking at these grand challenges at a global, from a global perspective. So you really need to start thinking, how are we going to train these scientists of the future so they can really work with others in the solution of the problems. So we have to have these strategies to support interdisciplinary research that in some cases will end up in cultivating innovation. Now, how do we normally train interdisciplinary scientists? In the US, we haven't done a very good job. We're trying to start new approaches, but in the past, we have just, like I said earlier, we just trained them in a very narrow focus, and we're trying to do something better. So here in this cartoon, the two men that are there said, I think you should be more explicit here in step 2. And step 2 says, then a miracle occurs. So it's like, this is how we have expected in the past that things are going to happen by a miracle, and if things don't happen by a miracle, you have to make a plan on how you want to train the students so it doesn't happen by miracle. It happens by a systematic planning. What I want to illustrate in this slide is that we start preparing students from pre-college, from elementary grades, all the way to career development. And there are many steps in between. There's undergraduate, then there is graduate, and then there is the early career. Did this die? No. What I put on the x-axis is, again, some of the grand challenges. And what I want to illustrate in this picture is that there has to be an integration of the research and the education. You have to have that hand in hand. As you are training the students in the research, you need to be looking at how education is going to be moving forward from the very beginning, from the time you start teaching a young person about sciences. This has to start from the very beginning. There has to be that connection between very early education through undergraduate, graduate student, and beyond. What I have here is an illustration of one of the attempts that the National Science Foundation have tried to do this integration of the graduate education and research. We have a program that we call IGERT, that is Integrated Graduate Education Research Traineeships. These acronyms are awfully long. And we are trying to learn to prepare the students with this interdisciplinary approach. And what we do is we select cohorts of people, group of students, and they go through a group. They go through workshops. They learn how to communicate. They learn specific skills also, not only on their research, but they also learn leadership. They learn entrepreneurship. They learn other types of skills that would help them work with others, and it will kind of open up their minds to be willing to work in teams with people in other disciplines. And also, we prepare them for careers that go beyond academia, because not everybody who prepares as a scientist is going to be a professor. Some of them will go to industry. Some of them will have their own business. Some of them will go and work for government, etc. And we also want our graduate students to be prepared to connect with the rest of the world. And in the US, we tend to be very isolating ourselves. But now science is a global endeavor, and we like to see our students connecting with students everywhere in the world. And I'd like to talk to you about this later. Basically, this IGERT approach is that have a base of this looking at the grand challenges and the societal problems and build from then. We have you built an education plan that, as I mentioned, with professional skills for the students, teamwork, global awareness, and we have sometimes internships for students in industry, and they learn about ethics. Ethics is an important thing to learn when you're a graduate student. When you deal with, for example, with patents, you need to learn about that. You need to learn about your data, how to be an honest scientist, and what are the issues that you have to deal with in ethics. We also like to have broader participation in all of our programs. And not only we want to attract people from all different ethnic and racial groups, but we also want to retain them. And finally, we have an outreach component. It's not only good to do your research, but you also want to share it with others. You want to disseminate your information, and you want to communicate your research to non-scientists. So some of these interdisciplinary themes that the IGERT projects have follow are in more specific areas. For example, smart sensors, the urban ecology, infrastructure, and I will show you some specific examples of some of these projects. This is one of the projects that I found particularly interesting. And the reason is this Osni Whitney is a student at Berkeley. He had an accident. Several years ago, he had a car accident and was paralyzed from the waist down. He couldn't walk. And so his fellow students in engineering decided that they were going to make him walk again. And what they did, they designed what they call an exoskeleton, and I will show you a video, hopefully it will work, of that he can put on, and as you can see here, he put it on, and he was able to walk. So to the point that this student stayed in school and was able to graduate from college. And you will see the video how successful this was. Let's see. So you can see what's possible for this student, how he was able to walk thanks to the creativity of his fellow engineering students who made that device for him to walk. He's the first person who can walk, actually, that had been paralyzed and walk. Now, this exoskeleton is also being used for other people who have had strokes, who have had any other problems with mobility. And of course, it's being perfected to be used by other type of people. But that just gives you a sense of what technology can do and the creativity of people that can come up to solve some of the grand challenges or some of the issues that we are dealing with. One of the many of the projects that we're funding, just to give you a sense for the types of interdisciplinary research that has emerged, are new fields. For example, we have this new field called astrobiology, that it's a mix of biology and astronomy. And for example, people are looking at life in other planets, or the possibility of life in other planets, especially with microorganisms, and assistive technologies. And you saw the video, what can happen. And then we have a lot of other areas that are related to coastal zones, and many projects that involve robotics and involve other fields altogether. Many of the, like I mentioned earlier, climate change is a big issue, and we have supported students to conduct research in areas related to biodiversity, for example, and see how climate change, the potential that climate change has on biodiversity. Malaysia is very rich in biodiversity, and it's going to be one of the challenges that you will be having here with your biodiversity and climate change in the future. We also have had projects that deal with what's happening in the poles, in polar regions, because there is environmental changes in polar regions. And the issues related to energy. We have supported very specific projects that students have worked in developing alternative sources of energy. This particular project is using wind energy to provide drinking water in some areas of Texas. So they're using both, a combination of alternative sources of energy to solve some issues related to water quality. And other students at the University of Delaware, again, are working with solutions for energy and combining solar energy with hydrogen generation. And I'm not an engineer, so I cannot really explain exactly what this project is all about. But just give you a sense that it takes also some issues related to economics and policies, because you have to think about the whole concept when you're looking at these issues. We also have supported students who have gone to the tropics. They have, some of students in the University of Florida have gone to Latin America and have looked at issues related to conservation of tropical forests. And they have also worked with government and with local indigenous groups as to what's going on in these regions. And also have trained students to deal with emerging diseases and how you deal with those diseases, preventing diseases, and also trying to figure out how you train people, local people, into diseases that have to do with, for example, with insects, with mosquitoes, and et cetera. And again, it has to be a team approach, because you want to have groups of students who really learn how to do this together. I want to switch a little bit. I know you all recognize President Obama, and I'm not trying to make a political speech in here, but the reason why I put him there is because he came to the National Academy of Sciences in 2009. And, oh, great. Okay. So President Obama came to the National Academy of Sciences in 2009. And one of the things that he was talking with members of the Academy that are very well-renowned people in their fields. And he was encouraging them to go to the classrooms, to go and visit young people. And he was telling them, I want you to spend time in the classroom and showing the young people what it is that you do and what your work means and what it means to you. He also started encouraging people encouraging the scientists to try to get young people engaged in science education, which is an issue that is very important in the US and Malaysia and many parts of the world. How do you bring young people into sciences? How do you excite them into sciences so they become, like President Obama said, they become creator of things instead of just consumer of things? And this is another approach that I wanted to share with you, that what the National Science Foundation has done, and this is a particular program that I have worked with. I have been very fortunate to have worked with, and we bring the graduate students in the sciences to K-12 classrooms. When President Obama said that, we were very happy to hear it, because we had been doing that already for a number of years, and it was like, oh, he's reinforcing it, what we're already doing and what we think is important. And this particular project has been very successful in encouraging young people to be doing sciences instead of learning sciences by just memorization of facts. The graduate students come to the classrooms, work with teachers, and then they bring innovative ways to get young people into the hands-on type of sciences, which is very exciting for them to participate in this kind of activity. And what that has done to the graduate students, a lot of graduate students, they train like scientists or like engineers, and then what they learned that this experience has done to them, they started learning how to communicate science in a let's say, non-scientific way, that they can communicate in better ways. And these are two quotes from the students that they say some scientists get so in-depth in the research that they forget or haven't thought about the importance of disseminating their findings to the community. So you really need to not only do good sciences, but other people need to know about it. And if you only teach your tell about your sciences to other scientists, something is lost there. And the new generations are not going to learn about it because their parents don't know about it, and it's all part of the same cycle. And so just to illustrate some of the ways that we have brought sciences to young people, is one of them is a project that we had in Puerto Rico called Science on Wheels. And they basically took labs to different parts of the island of Puerto Rico and set up demonstrations where the graduate students were doing chemistry and physics. And you can see in one of the pictures that's a large group of students that were there involved in this project, and just looking at it, what the graduate students were talking with them and interacting with them about what's going on in their experiment that they were running. They also bring them to the field, and the graduate students come to the classrooms and bring the research to the young people. And also, we have been able to engage young people directly in research that is happening in their own place. This project is in Utah, and there is a project related to water quality. Again, we're talking about big challenges. Water quality is important there. And this young girl there, she's actually analyzing water samples. And then the data that she's collecting is actually being part of a large project being conducted in the state of Utah. So she's learning sciences, she's contributing, and she's learning how sciences is being done. So what I have here is a couple of videos, again, that are made by students to show you how else students are seeing the world, the future, and how they're addressing some of the grand challenges. So he sees himself as creating the future, and then he's very lucky that he's doing research in Iceland. But the main thing he wants to convey here is that he wants to really bring other people and share his sciences and disseminate the sciences with the young people and with some of his friends, which is one of the things that we're trying to encourage when we train scientists, that is not only doing good sciences, but also learning how to communicate that science to the public so others understand what it is that you do. Like President Obama said, it's important that you tell others what the work means to you and what your work means. But you have to talk about it in a way that other people understand. So I hope that I have shared some of the thoughts with you, and you might have some questions. I don't know if the DVD will work, if we can try it. That will just give you also a sense of what other kinds of research and how the National Science Foundation works. It's only a 5-minute video. The way this GK12 program has worked is we are a funding agency, and it's the universities and the schools that decided what they want to do. And they have submitted the proposals to us. And if we find them, we get them reviewed by experts, and if we find them that they have good ideas and if they're feasible, then we provide the funding. But we don't tell them what to do. It all comes from the communities, it all comes from the researchers or the education people. It is all based on their own place and their own reality. For example, we have had projects, we have had 306 projects over the last 12 years. these are big projects, 5-year projects, $3 million each. But then, for example, if you are in Alaska, your realities is very different. You know, the issues that you might have to look into, the schools in Alaska might be very rural, it's very cold most of the year, are very different than if you're in California or if you're in New York City. So, and we have, excuse me, and we have had projects in all of these areas. So, so it depends on the strength of the university, it depends on the interest of the school, and it depends on what it is that you want to do and how you want to connect. So, for example, here in Malaysia, you can look at this at UTM. When I visited on Tuesday, I saw that you're working on, well, there are projects here related to aerospace engineering, electric cars, and other kinds of things related to manufacturing of cosmetics and virgin coconut oil and all kinds of things. So you have to look at how can you connect with the schools and the research that is being done here, how that can be brought to the schools so to connect with the young people and how the young people can participate in your research. Sometimes it's feasible, sometimes it's not. But you have to look at what is possible to do here. So does that answer your question?
In a way, but just to follow up on the feedback earlier, is community engagement projects, for example, going to communities and conduct science on wheels, for example, as part of the criteria to grant all the research funds?
Yes. Okay. Now, what happens is that I need to clarify this. The graduate students received a fellowship. And so we pay them so they can go to school and be doing their research. But in exchange for that, they are expected to spend 10 hours a week working with teachers and young students, being in the classrooms. Thanks for asking that question, because I know that was missing. So you get paid to be a graduate student, you get your fellowship, but nothing comes for free. You have to return those 10 hours a week working with the teachers and bringing your research and teaching, bringing your sciences to the classroom. The good thing that does also is that if you're a young scientist or a young engineer, when you go to the classroom, the young people look at you as a role model. They start looking at themselves and seeing they're not, oh, I could be an engineer or I could be a scientist too. It's different than if you bring an older person to a classroom. The difference in age is too big. And then the young people cannot identify with them. But they can identify with the students that are still in school, and they can ask them questions. So that's one of the good things about bringing graduate students to the classrooms, because the young people start saying, oh, you're an engineer, or you're going to be an engineer, you're a woman, you know, I can be an engineer too, or I never thought about studying whatever, you know, biotechnology, aerospace engineering, electrical, whatever it is. And then also the young people can ask questions about what it is like to be trained as a scientist, what kind of jobs you expect to get, something that a lot of people, at least in the States, a lot of the young students in the schools have no idea what happens at the university. They have no idea what people that go into sciences or engineering, they do, what they do. A lot of people have no idea what it is that you do as a scientist. Besides teaching, people have no clue that there are many options, or many career options, especially now. There are a lot of careers that haven't even been created. So I think that it's very good to have that connection. But that is the trick, that you pay them, you give them a fellowship, and then that's how they're expected. It's part of the deal, it's part of the condition that you are, in exchange, you go and spend that time working with the teachers in the classrooms. Yes. Thanks for the clarification, for the question. Yeah. Other questions? Yes.
I'm retired professor.
Yeah.
Do you give grant only to universities or to the industry as well?
We give grants to mostly, NSF provides support mostly to universities, but we also have, like you saw in the video, we have a program that is for small business, and it's sort of like for starting up grants. So if somebody wants to start a business, we provide a small like seed money, like $20,000, and then they can, just for the beginning, for the basic research, and then they move on their own to get, to when the industries grow.
Another thing, when you mentioned about the student need to get some fellowship to serve community, of course his supervisor will get involved.
Yes, the supervisors do get involved.
Any merit for promotion for doing that?
Yeah, you know, one of the things that we have in the U.S. is this, and one of the criteria that NSF has is this, what you call broader impact. And then it's like your research, when you submit a proposal, you write about what it is that the research is going to be, but you also have to write something about what's the potential impact of your research basically on society. And some of it is also how your research or how you're going to get young people involved. If you're going to train people, if you're going to be teaching, that's part, it's a very important component. And it does help with promotion. Yes.